Hello, I'm Robert Benavides, and my topic is exception handling. First of all, I just want to talk about this in a very general kind of way, and then we'll drill down on our chapter, which is Chapter 10, Files and Exceptions. Now, this particular topic has to do with what happens when you get errors. Now, people usually say, or programmers usually say, that there's three kinds of errors: syntax errors, logic errors, and runtime errors. The syntax errors, those are the ones that you get when you're typing in your code and you get a little feedback that you typed it in wrong in your editor. Now, the logic errors is when 1 and 1 is 5, and you got to figure out why. You don't have any kind of runtime or syntax error, but you're getting an answer, but it's the wrong answer. So that leaves us with the runtime errors, and that's when your program works most of the time, but sometimes the user does something that causes the program to crash. Like, let's say you're asking for two numbers that's going to end up doing a division, and they enter in 0 for one of those numbers, and you well know we can't divide by 0. Or you're asking them for numbers, and they, instead of numbers, they type in text. Or the program requires access to a particular file. That file doesn't exist. All of those situations are going to cause your program to crash. That is what we want to zero in on. How can we exit the program more gracefully? There's two reasons why we want to do this. Number one, it's not good for beginners or clients that are using our program for them to experience this crash. And number two, hackers can end up seeing the traceback, and they can get information that can help them to hack into the system. So those are two reasons why we want to talk about this topic in more detail. It's a finishing topic. Usually you do this after your program is mostly done on here. So that's why a lot of times you'll find this topic at the tail end. But in Python, the general scheme for handling errors is you've got a try block where you put things in where you're going to do code where you think something might happen that causes an error. And if there is an error, you'll use a variety of exception clauses. And then you can also have an else and a finally. Your book doesn't cover all of these, but that's the general idea. It's try, except clauses, an else, and a finally. Now, usually you'll try and catch as many kinds of problems. Like, say, for example, you may want to catch for the division by 0, the value errors, which would be like when you're typing in, you're asking for numbers and they type in TEN instead of 10, or the file doesn't exist. So you may want to list all of your specific exceptions first, and then it's acceptable practice to list a generic one at the end that catches all. Your book doesn't talk about it, but there is a general exception that they can catch any kind of problem. The only problem with that is the feedback is not very specific. Like, if you only have that, then you only say, hey, an error happened, but you don't know what kind of error. Whereas if you had a very specific exception, such as the division by 0 exception, and if that exception caught, then you know exactly what happened. There was a division, 0 division error, right? So you typically will list your specific ones and then end with a generic one. And what happens here is that if one of those situations happens, then those exception clauses will fire. Then if nothing happens, if no problems happen, the way it works in Python is that the else clause will then go ahead and go into effect. And then at the very end, there's a finally clause. Your book doesn't talk about it, and that's because the finally is usually used for, like, let's say you have a very large application dealing with databases, and that's where you would handle those maintenance tasks such as closing files and things of that nature. So let's go ahead and start at the very beginning. Now, that was just my general ideas about errors and Specifically the runtime errors are the ones that we're going to be writing this code for. So what are exceptions? Python uses special objects called exceptions to manage errors that arise during a program's execution. Whenever an error occurs that makes Python unsure what to do next, it creates an exception object. If you write code that handles the exception, the program will continue running. If you don't handle the exception, the program will halt and show a traceback, which includes a report of the exception that was raised. In other words, what other people would call it crashed, right? So how are exceptions handled? Exceptions are handled with try except blocks. A try except block asks Python to do something, but it also tells Python what to do if an exception is raised. When you use try except blocks, your program will continue running even if things start to go wrong. Instead of tracebacks, which can be confusing for users to read, users will see friendly error messages that you write. So we're going to first start with our first example here with the handling the division or the handling the zero division error, or that's when you divide by zero, which is, as you know, it's a no-no in math and in programming. So let's look at a simple error that causes Python to raise an exception. You probably know that it's impossible to divide a number by zero, but let's ask Python to do it anyway. So here I have my first example here, and it's just one line of code, and it says that we're going to try and divide, by zero. So let me go ahead and run this and see what happens. So here we go. We've got the traceback, and what does it say? Let's just go ahead and look at this. It says that the problem is on line 3 in red. It even tells me the file. Okay. Then down at the bottom, the traceback repeats this information again, that it's on line 3, and it tells me the name of the file. I've got a long path there. And then it gives me the name of the exception, which is called zero division error. And then it breaks it down into real English, division by zero. So what we want to do here is we want to be able to not have this happen. We want to be able to exit the program gracefully and provide some kind of feedback to the user if they do indeed do something like this, And of course, this is just an extreme situation. I mean, usually it would be something like where you prompt the user for some inputs, and then it goes into a formula, and you may not have been expecting them to enter in a zero, but they did, anyway. So that's what happened here. So the error reported in the traceback, the zero division error, is an exception object. Python creates this kind of object in response to a situation where it can't do what we're asking it to do. When this happened, Python stops the program and tells us the kind of exception that was raised. We can use this information to modify the program. We'll tell Python what to do when this kind of exception occurs. That way, if it happens again, we're prepared. So this is, I think, a really good start here. It's the idea that we're going to write our program first without exception handling being built into it. We'll experience these tracebacks, and then we'll look at the errors that occurred, and then we will create these exception objects to go ahead and handle these situations. So using try exception blocks, when you think of an error, when you think an error may occur, you can write a try exception block to handle the exception that might be raised. You tell Python to try running some code, and you tell it what to do if the code results in a particular kind of exception. And if no one's told you, I mean, since this is a beginning class, some people say, well, why do they call them exceptions? Because the idea is that it is an exception to the rule, right? I mean, the program should work, right? So if it's crashing, it is an exception, right? I know it's kind of like it's like we can't say error, as a programmer, we have to come up with a fancy word, but that's where the word exception comes from. It is an exception to the rule that the program, should be working. So let's go ahead and look at a try except block for handling the zero division error. Let's see what it looks like. So let's take a quick look at this code. See, I have a try block on line 4. I'm doing the code that I think could possibly result in the zero division error. I go ahead and on line 6, write my except block, and notice that if that happens, then it will print out you can't divide by 0, right? So let me go ahead and run this, and it works just fine, right? So it did happen. It, instead of giving me all that traceback stuff that's not good for users, and it's not good for not good for us, because hackers can use that information in a bad kind of way. So we put the print 5 divided by 0, the line that causes the error, inside a try block. If the code in the try block works, Python skips over the exception block, right? So that, like, say, for example, right? So see how it skipped over the exception block? Probably should have done that. We could do that in a debugging, but I think it's pretty easy to understand that Python skips over the except block. If the code in the try block causes an error, Python looks for an except block whose error matches the one that was raised and runs the code in that block. So notice this is a very specific exception. I could have said except and then just the word exception, and that would have caught all errors. He doesn't cover that. That's the generic one. The bad part about the generic one is that you don't know exactly what happened. With this specific one, you know exactly that is what happened. So if you had the generic one, you would just have to say an error occurred. You wouldn't be able to be very specific about it. That's why people typically list it at the very end of a long list of very specific ones. So in this example here, the code in the try block produces a zero division error. So Python looks for an except block telling it how to respond. Python then runs the code in that block, and the user sees a friendly error message instead of a traceback. If more code followed the try except block, the program would continue running because we told Python how to handle the error. So now let's go ahead and look at an example where catching an error can allow the program to continue running. Right? So in this next section, we're going to talk about using exceptions to prevent crashes. So handling errors correctly is especially important when the program has more work to do after the error occurs. This happens often in programs that prompt users for input. So if the program responds to the invalid input appropriately, it can prompt for more valid input instead of crashing. Right? So that's what we don't want to do. We don't want to crash, right? So let's create a simple calculator that only does division, right? So in this particular case, it says, give me 2 numbers and I'll divide them. Enter Q for quit. And it's in a while block. Okay. So using exceptions to prevent crashes. This program does not handle errors. So asking it to divide by 0 causes it to crash. So this doesn't do any handling of anything. What we're going to do is we're just going to set ourselves up, to crash. So let's create a simple calculator that does only division. Okay. And so this program prompts the user to input a first number And if the user does not enter quit a second number, we then divide these two numbers to get an answer. This program does nothing to handle errors, so asking it to divide by 0 causes it to crash. So let's go ahead and do that. Let's go ahead and run it. Now it's an input, so remember that Sublime can handle input. So I'm going to go ahead. You could go ahead and use Visual Studio Code for this. The way I'm going to do this is I'm going to just go ahead and bring up CMD. I already got it up. I navigated to that folder, and then I'm just going to go ahead and run it from here. So the name of the way you run it is you say Python, and then the name of the program that you want to run, which is division underscore calculator 3.py. Okay. If you want, I can make this a little wider. It's got a very long prompt because I've got many to get to where the folder I'm working in. I have a long prompt on here. So if I spell that right, it should work. So it says, give me two numbers and I'll divide them. So I'm just going to go ahead and go right to it. I'm going to say 5, just to continue with the same idea. And then I'm going to go 0. Okay, which was the equivalent of that print thing. It was just that we created more code here to make it look, more like a legitimate kind of question, on here. And we're going to experience the traceback now. So now we get the 0 division error, division by 0, and the program crashed. So that's not good, right? This is what we don't want to experience. We don't want our clients to go through this. We don't want hackers to see this, as well on there. So why is it bad for the program to crash? It's bad that the program crashes, but it's also not a good idea to let users see traceback. Non-technical users will be confused by them, and in a malicious setting, attackers will learn more than you want them to know from a traceback. For example, they'll know the name of your program file, and they'll see a part of your code that isn't working properly. A skilled attacker can sometimes use this information to determine which kind of attack to use against your code. So not good, right? So that brings us to the else block. So we can make this program more error resistant by wrapping the lines that might produce errors in a try except block. The error occurs on the line that performs the division. So that's where we'll go ahead and put the try except block. This example also includes an else block, and any code that depends on the try block executing successfully goes in the else block. So let's go ahead and look at that. Let's look at the code. So the only thing different, let's see, I'm going to say the only thing different on here is we're doing the try block right here, because this is where we're going to catch that particular error. Now, certainly there could have been other problems, like if you say enter in the first number and they put in TEN instead of a number, then that's going to cause it to crash up here. But let's just talk. We're continuing to talk about this 0 division error. We're catching one particular one, not a generic one. So as you can see here, in this loop, I asked for one number. Okay. And if I enter in Q, it breaks. I ask for another number. Then I go ahead and convert those strings to ints and get an answer. This is the try. Okay. This is where we could possibly get a 0. Okay. And I guess also, this would be also where you would get the error for example, if they typed in TEN. I didn't notice where they had, I was expecting to have the INT conversion up here at the top. But if you're doing it down here, you could probably end up catching that as well. Okay. So here we have an except block called zero division error, and it's looking for a particular error. So if we did this and we did it right, it's going to go and print the answer. It's going to go ahead and do else. Okay, so let me go ahead and run this inside of here. And this is calculator 4. Then just press the up arrow and come over here and put in a 4 in front of that 3. That one I have to type in the whole darn thing. So if I enter in the first number and then I enter in the second number, you know, if I would have put in 1, it would have gone to the else, right? In fact, let me go ahead and just show you. See, so I get my answer, right? So let me go ahead and we have a while, so I can go ahead and continue here. You can't divide by 0, right? So in other words, it didn't crash, and my program continues to loop. That's what we want to do. We want the program to continue working. That's the whole idea. I'm going to put in the little Q so I can get out of here and come back to my code. So hopefully you see the importance, or you're seeing the structure here a little bit better. You've got try, except, else. We're not going to talk about finally because we don't have any application. We're not dealing with like maybe a database where we would need to be closing the database files and things of that nature. Okay. So the try, except, else block works like this. Python attempts to run the code in the try block. The only code that should go in a try block is code that might cause an exception to be raised. Sometimes you'll have additional code that should run only if the block was successful. This code goes in the else block. The except block tells Python what to do in case a certain exception arises when it tries to run the code in the try block. So by anticipating likely sources of errors, you can write robust, there's that important word again. You can write robust programs that continue to run even when they encounter invalid data and missing resources. Your code will be resistant to innocent user mistakes and malicious attacks. So how do you anticipate this? Well, I guess the first thing you may want to do is just test your program really well. And you know, when you're running the program, if you're experiencing error, then you would write the exception for it, right? So you pay attention to the tracebacks. The traceback is very informative to you. You're not going to want that program to go to the client with you know, these kinds of problems. So handling the file not found error, that's another kind of error. So in this chapter, we talk about the zero division error, the file not found error, and I think we also talk about the value error. That is, you know, like when you type, if I ask you for your age and you're expecting like 23, the number 23, and they type in 23, well, it'll choke, you know. So so you can make a whole chapter out of this topic. Because you can, what you usually have is these chapters on exceptions. They go through a long laundry list of all the different possible kinds of exceptions, so that really an experienced programmer wants to spend time, you know, with the library and learning what exceptions could possibly happen. So handling the file not found exception is our next topic area here. One common issue when working with files is handling missing files. The file you're looking for might be in a different location. The file name may be misspelled, or the file may not exist at all. You can handle all of these situations in a straightforward way with a try except block. Let's try to read a file that doesn't exist. The following program tries to read the contents of Alice in Wonderland, but I haven't saved the file, you know, alice.txt in the same directory as Alice, you know. So let's go ahead and look at that. So there's two changes here. One is the use of the F variable to represent the file object, which is a common convention. Okay, so Yeah, I know we talked about descriptive file names, and I've often said, don't use just I, don't use just X, don't use just Y. Well, in this case, F is a common convention, so it's okay. All right. So you got to learn when it's okay, and this is one of those situations. So the second is the use of an encoding argument. This argument is needed when your system's default encoding doesn't match the encoding of the file that's being read. Python can't read from a missing file, so it raises an exception, right? This topic of UTF-8, I mean, you could spend a lot of time there, but UTF-8, that includes all the different possible kinds of characters. It's a topic in itself. I invite you to go ahead and research it. So basically what's going to happen here is if you run this, and if that file is not in the current directory, right, then you're going to have a traceback. So let's go ahead and see. I don't remember if I have that file there. If not, I'll go ahead and delete it. So let me go ahead and run this. So no, it's not. It's not in that folder. So needless to say, if it was in the current folder, so if go file, for example, file open, I don't see it in there, in that folder. So if it would be there, then you wouldn't have this error, right? So what we want to do is we want to go ahead and handle that situation. So the last line, here's the traceback on here, and I'm just making it big so you can look at it. It tells you what line you got the problem, what line the problem occurred in, and what's the name of it. It's called a file not found error. No such file or directory, alice.txt. So this is the kind of feedback that you need to know to understand. And I've seen all the situations, just like what the author said. You could have misspelled the file name. Maybe you're missing a character. Maybe the file doesn't exist. Maybe you put them in a separate folder and you forgot to change the code. Let's say that you started building and the file was in the current folder, and then you ended up having to have many different files. So you say, I'm going to go ahead and put all my text files in a separate folder as a child in the parent directory, and then you forget to go ahead and change the code. See, these are all the possible situations. If that was a situation, then you would have just changed the path, to it. So what's important here is learning how to read these tracebacks. As a beginner, many times they don't look at these tracebacks because they don't understand them. And right now, it's important that you understand these tracebacks. These tracebacks are telling you what happened so that you can go ahead and figure out how to go ahead and handle this situation. Okay. So in this example, the open function produces the error. So to handle it, the try block will begin with the line that contains the open. Okay, so let's go ahead and look at our next example here. Right. And let's go ahead and run it. So in this case, it says, sorry, the file Alice does not exist. Okay, because it does not exist, right? So it caught that we exited gracefully, right? We did not crash. We did not see a traceback. So in this example, the code in the try block produces the file not found error. So Python looks for an except block that matches that error. Python then runs the code in that block, and the result is a friendly error message instead of a traceback. The program has nothing more to do if the file doesn't exist, so the error handling code doesn't add much to this program. So let's build on this example and see how exception handling can help when you're working with more than one file. So let's talk about analyzing text is our next topic. So let's pull in the text of Alice in Wonderland and try to count the number of words in the text. We'll use the string method split, which can build a list of words from a string. Here's what the split does with a string containing just the title Alice in Wonderland. So let's go ahead and take a look at this in our next example. I'm going to go ahead and run this. I got a sequence of my file names. So I assign Alice in Wonderland a string. I create a string variable on line 1, and then I use the split method on that string, and that gives me a list in which that string is then separated into words. Okay. Of course, then we can just use the length property on this to go ahead and count. So the split method separates the string into parts whenever it finds a space and stores all the parts of a string in a list. The result is a list of words from the string, although some punctuation may also appear with some of the words. To count the number of words in the Alice in Wonderland, we'll use the split on the entire text. Then we'll count the items in the list to get a rough idea of the number of words in the text. So let's go ahead and take a look at that. Okay. So let me go ahead and run this. And you're probably wondering, why did this work and the other one didn't? Is because I have this in a separate folder. Okay, so I'm going to go here, go to File, New. Oh, no, I didn't want to do that. That was too fast. File, Open File. I'm in Analyzing Text. And then, so if there's file missing, there's a separate folder for that concept. So I have different folders for the different ideas that I'm working on. Okay. So the file is about let's see now, 29,465 words. All right. Let me go ahead and look at that again. I'm going to go ahead and look at that inside of my. I'm going to go ahead and use the File Explorer so that I can navigate through my folders structures again. So I think I've got everything inside of Python Work. I've got it inside of this folder. And then this is chapter 10, right? And then we're in part 3. And then we're in Analyzing Text and then File Missing. So Analyzing Text has the Alice file, whereas the File Missing does not. Okay, yeah, I wanted to verify that. Okay, good. So that's why this particular one is pathed out to the folder that does have the file, whereas the other one did not. Okay. So, the else clause fires because it found the file here. So we say try opening up this file, read it into contents. So except block does not fire at all. The else block goes into effect. And the way we do this is that we're getting that file called contents. And we're using the split method to create this list of words. Then I'm going to use the length function on this list to find the number of words. Then lastly, on line 12, I'm going to create a formatted string that says the file, which is file name, alice.txt, has about, and it was an approximation because there's some variations if you study this a little bit more, has about, 29,465 words. And that is, if you look at that file, you'll notice that it is the Alice in Wonderland file, on here. Let's see. Analyzing text, double click on it. And here is the Alice in Wonderland text that was downloaded. Okay. I always like to go ahead and look at stuff. I don't like to just um, to just blindly accept the fact that it's there. You know, I think it's important to verify that there is a file. And I ended up using different file structures to simulate these different concepts. Okay. So I moved the Alice file to the correct directory so the try block will work this time. To take the string contents, we take the string contents, which now contains the entire text of Alice in Wonderland as one long string, and use the split method to produce a list of all the words in the book. When we use the len, or length, right, function on this list to examine the length, we get a good approximation of the number of words in the original string. We print a statement that reports how many words were found in the file. This code is placed in the else block because it will work only if the code in the try block was executed successfully. The output tells us how many words are in the else block. So in other words, watch, here it is. You try to open up this file. If the file doesn't exist, the except block fires, and then the else block does not fire. If you try and open up the file and it's found, the except block is skipped and the else block is fired, okay, or executed. So let's talk about, you know, working with multiple files. Let's add more books to analyze. But before we do so, let's move the bulk of this program to a function called count words. By doing so, it will be easier to run the analysis for multiple books. So let's go ahead and take a quick look at this code, see how it works. And running it, we get the same thing on here, right? So now we've got, what was the difference? Oh, we put it into a function. Okay, I got it. See, like on line 1, we defined a function called count underscore words, and it receives file name. So the program kind of like starts here on line 13 and 14. So I assign alice.text a file name, and then I pass file name to count words. So the flow of control leaves line 14, comes all the way over here to line 1, and goes through this function. The function contains the try catch. Excuse me, I'm still thinking of Java, sorry. Can you tell I come from a Java world, right? So it's a try except block. Try except else finally scheme, you know. Just remember here syntax, I don't know if I forgot to cover it. At the end of the try, we put in the colon. At the end of the except, we put the colon. At the end of the else, we put the colon. That's the proper syntax for this, okay? So if we want, we can go ahead and write a simple loop to count the words in any text we want to analyze. We do this by storing the names of the file that we want to analyze in a list, and then we can go ahead and count words for each file in the list. We'll try to count the words for Alice in Wonderland. I don't think I can pronounce this right. It's Siddhartha. It must be a classic book, but obviously I wasn't exposed to that. Okay, I know about Moby Dick. I know about Alice in Wonderland, but I never. I'm gonna have to research that book called Siddhartha, and the one called Little Women. I don't know about that one. I don't know, but anyway, we'll just go ahead and you know, accept that there's these files with these books, which are all available in the public domain. I've intentionally left Siddhartha.txt out of the directory containing the word count, so we can see how well our program handles this missing file. So let's go ahead and take a quick look at that. And let's look at this in code. Let's look at all the code before we run it. So what's new here? What's new is that on line 13, because the overall structure of this is the program pretty much starts here on line 13, 14, 15, right? Then it calls this method and it comes up here, right? And it finishes on line 11, right? So what we're doing here is on line 13, I'm creating a list, and this is a list of files. The first file is called alice.txt, Siddhartha, Moby Dick, and needless to say, this is in a folder that contains all the files that that are required for this demo. So let me go ahead and show you what I'm talking about here. It's called working with multiple files. So I put in all the stuff related to this one idea in here. I've got the Little Women, the Moby Dick, and the Alice.txt, and he said we're leaving out the other one. Okay, so we're leaving out the other one so that we can see how the logic of this program. So let's go ahead and see what happens here. I create this list, and then I say for file name in file names, what I want to do, I want to go ahead and then pass that file to count words. So that file comes in on line 1, and we attempt to open it. And then we go through. This is beautiful. This is beautiful because after it does this for the first file, it goes and does it for the second, and then the third, and then the fourth. Okay, so let's go ahead and run this, and let's see what the output looks like. So yes, it runs it for Alice, and then the accept block fires for that Siddhartha file. And then yes, it did find Moby Dick, and it found Little Women on there, giving us the count of words. So this is working. This is an excellent example of how you can use a try except block to deal with errors and have the program continue working. So basically, if you wanted to see what this would look like, take out the try except else thing and just have it like plain code, run it, and then you're going to see that when it gets to this Siddhartha file, it's just going to crash and it's not going to continue going. So that's the main idea that we're trying to bring out here, or that Eric is trying to bring out here, is that we want to be able to write a program that will continue, right, to run despite experiencing an error. Excellent, excellent example. So using the try except block in this example provides two significant advantages. Number one, we prevent our users from seeing a traceback. So we don't want our client, it's not professional. It confuses beginners, and it's a terrible impression if you sell something and you get tracebacks. It's not good, right? And then we also let the program continue to analyze the text it's able to find, the text it's able to find. So it continues to work, right? If we don't catch the file not found that Siddhartha.txt raised, the user would see a full traceback, and the program would stop running after trying to analyze Siddhartha. It would never analyze the Moby Dick and the Little Woman. Excellent, excellent, excellent example. So now that brings us to the topic of failing silently. I just noticed in my notes I wrote it down as falling silently. Well, I guess you could do that, but we're talking about F-A-I-L, silently. And this is a really neat idea. And I see a lot of programmers use this technique that we're going to talk about right now when they're working with methods. And so let's talk about failing silently. So in the previous example, we informed our users that one of the files was unavailable, but you don't need to report every exception you catch. Sometimes you'll want the program to fail silently when an exception occurs and continue on if nothing happened. To make a program fail silently, so it's important to understand, is that in this case, we don't want any kind of feedback. We just wanted to just, don't crash, keep on going. That's what we're trying to say here. So to make a program fail silently, you write a try block as usual, but you explicitly tell Python to do nothing in the exec block. Python has a path statement that tells it to do nothing in a block. And that's what we see there on my line 7 that I have there. So let me go ahead and run that. Look at the output. So it just didn't respond that the file, it didn't say, hey, I don't, I can't find it kind of thing, It just went ahead and worked on the ones that it could find. Excellent little demonstration of failing silently. So the only difference between this listing and the previous one is the pass statement. Now when a file not found error is raised, the code in the exec block runs, but nothing happens. No traceback is produced, and there's no output in response to the error that was raised. Users see the word count for each file that exists, but they don't see the indication that a file wasn't found. So the pass statement also acts as a placeholder. It is a reminder that you're choosing to do nothing at a specific point in your program's execution, and that you might want to do something there later. For example, in this program, we might decide to write anything missing, write any missing file names to a file called missing_files.txt. Our users wouldn't see that file, but we'll be able to read the file and deal with any missing text. Now, I've also seen people use pass when they're creating a whole bunch of functions, and they just want to go ahead and create the definition and write the inside later. So they just put the word pass. So they're just going for like the overall big structure of their program to connect all the parts. And then they go back and fill in the middle of the Oreo, if you will. So that's that about that. So let's talk about deciding which errors to report. Giving users information they aren't looking for can decrease the usability of a program. Python's error handling structure gives you fine-grained control over how much to share with users when things go wrong. It's up to you to decide how much information to share. So yeah, this concept of exception handling, there's a lot to it. Like I said, you can write a whole chapter on this. So well-written, properly tested code is not very prone to internal errors such as syntax or logic errors. But every time your program depends on something external, such as user input, the existence of a file, or the availability of a network connection, there is a possibility of an exception being raised. A little experience with help, will help you know where to include exception handling blocks in your program and how much to report to users about the errors that arise. So yeah, as you can see, look at all those different circumstances. And what if the network's not available? Well, then your program crashes, right? You probably want to be able to exit this more appropriately, more professionally, rather than just, because then people get upset when they see the trace back. It just doesn't go over really well. So let's talk about the try it yourselves. And in the try it yourselves, this is pretty good. This is where we talk about the value error. So you can't skip the try it yourselves, because many times the author will introduce concepts here that will, I think, make the reading of the chapter incomplete. Like in the try it yourselves, Eric talks about the value error. This is really important. So if you were to have skipped this, you would be missing a very important idea. I'm going to go ahead and do the try it yourselves with Visual Studio Code. So just so we can do something different on here. So let me go ahead and open that up. And I'm going to try it one way, and then I'm going to try it another way. Okay. So first of all, let's say I just want to go ahead and open up 10.6. So if I go File, Open File, let me see. where do I have my stuff? I have it in Python work, and then in here, and then in here, and then I'm in exceptions, and then try this. All right. So if I go ahead and let's go ahead and look at the first one on here, the first demo here. And so it asks for input. And it says, give me a number, and then we convert it to an int, and then give me another number, then we sum it. You know, we could just, I know that some people may say, I'm going to go ahead and write this with the try except block already written, but you probably want to go ahead and just experience it like this first. So let me go ahead and run this. And it says, give me a number. I'm going to go down to the bottom, and I'm going to put in a 10. And then another number, I'm going to go ahead and put in the 0, which I know is a no-no, right? Let's see. Oh, we're doing a sum. All right. Let's see. Give me a number. Give me another number. And then so we're doing the sum. Oh yeah, I know. We're going to go ahead and try. Yeah, this one. This is not the divide by 0 error. This is the value error, and that's when that. Let's say that you want to go ahead and sum two numbers, and let's say I want to type in a 5, and instead of typing in a 5 like this, your troublemaker user types in FIVE, and now you get the value error. Okay. Now, one way around all of these exceptions is don't even give the user the opportunity to create an error. Like, for example, if you have an application that has a GUI and they have to select from drop-down lists, and those drop-down lists have all the numbers that would not create errors. In other words, it would have the number 5. So if they select from the drop-down list and they select the number 5, you're never going to get the value error. Yeah, but we haven't covered GUI yet. You know, so GUI is a really important thing to learn because it can go ahead and eliminate, if you a well-designed interface can eliminate a lot of problems. Okay, so let's take this up a notch and go to the next example on here. So now I'm going to go ahead and run this. And it says, give me a number. I put in 10. And now I'm going to go ahead and type in 5 again, right? And let's see what happens. See how it says, sorry, I really need a number. Now, we're not using this in a loop. You know, we could, but that would just be complicating this. The idea here is we have a try. And if there's a problem, the except block will fire. If there isn't a problem, the else block will go ahead and do the summation and print the sum of the two numbers. And yes, I know we're using X and Y, but in this particular case, I do think it's okay to use X and Y. It's just a simple little demo. It's not it's a little toy program. It's not, I mean, it certainly could have said one number, another number for the variable names, but X and Y seem to work out pretty good here. So a common problem when prompting for numerical input occurs when people provide text instead of numbers. When you try to convert the input to an int, you'll get a value error. Okay. So right here is where the problem occurs, right? If I try and convert TEN to an int, you know, it's not going to be able to handle that. It's going to choke. It can convert a 10, but the string 10, but not the words TEN, right? So when you convert the input to an int, you get a value error. Write a program that prompts for two numbers, add them together, and print the result. Catch the value error if either input value is not a number, and print a friendly error message. Test your program by entering in two numbers and then entering in some text instead of a number. So I did it once without the exception handling so I could experience the traceback. I think it's important to experience the traceback. And then once I know what the traceback is, that I experienced, that I had a value error, then I go ahead and write that particular block to handle that error. Okay, excellent little demo here. And so now let's talk about the 10.7, the addition calculator. So now we're going to wrap your code from exercise 10.6 in a while loop so the user can continue entering numbers even if they make a mistake and enter text instead of numbers. So let me go ahead and open that one up. Go ahead and delete the output and start again. So it says, give me a number. I'm going to put in 10 and 10. Let's just do it right so it works right. So then if I put in 10 and then to en, sorry, I really need a number, right? So now we can just go ahead and quit, right? So now we know it's working just fine. Excellent, excellent little demo. Let's look at the code that does that a little bit more precisely. So our code from before was this try block, right? And all we did is we put it inside, we embedded it inside a while block or a while. And we had to, when we do that, we have to perform a test to get out. So on line 3, we say enter Q at any time to quit. And we enter in the first number and we check to see if it's equal to Q. And if it is, we break. And all we have to do is write that code once, and you do a Control-C, and you put it in down over here again, and just change that X to Y. Yeah, I do a lot of cut and paste. It can either help you or hurt you. Like say, for example, if I forget to change that X to Y, then I've got a problem. Then, I could introduce some logic errors in here, right? But that's 10 point. Let's go ahead and 7. Let's go ahead and take a look at 10.8. It says make 2 files, cats.txt and dogs.txt. Store at least 3 names of cats in the first file and 3 names of dogs in the second file. Write a program that tries to read these files and print the contents of the files to the screen. Wrap the code in a try except block to catch the file not found error. And then print a friendly message if the file is missing. Move one of the files to a different location in your system and make sure the code in the except block executes properly. Okay, so let's take a look at that. So I'm going to go ahead and run it. Now, in this particular case, I know for a fact that those files are in that folder. This is what I've been trying to talk about, and I sometimes spook myself out about it. This doesn't seem to be an issue with Idle or Sublime finding the files. But I know the files are there in that current folder. So why is it saying that it can't find them? This happens with files. What I need to do is open up the folder first. Let me show you what you should do. When you're working with files, you need to go ahead and do File, Open Folder, and navigate to that folder. I'm going to try this, right? Select the folder. See how it popped in all my files and my text stuff? So if I want to work on 10.8, double click on it. I'm going to close these other ones so that they don't, overcomplicate things. So let me go ahead and run it now. See how it found them now? See how it says that it's reading the file? Okay. So it's working just fine. I'm going to break it in just a minute, but for right now, let me just go ahead and look at the code. So what happens is that I put 2 files in a list. Then I'm going to navigate through these files, and I'm going to go ahead and do a try except block. I'm going to say open. I'm going to put all that stuff inside the file into a variable called contents, and then I'm going to print the contents, right? That's what I want to do. And so the idea here is this. Remember, let's don't lose sight of the directions here. It says make 2 files, cats.txt and dogs.txt. Store at least 3 names of cats in the first file and 3 names of dogs in the second one. Well, what did I do? I created cats. Let me show you my cats. Allie is my cat. We used to have a Willie, and I couldn't think of another one, so I just put Mo. Okay. Then dogs. I have. There's probably a dog called Willie, and then there's 2 other ones there. Okay. So there's my text files. You have to create those first. Okay. So that when you run this, it's going to print the contents of that. It's going to go ahead and say reading the file. Let me run it again so you can verify this. See how it says reading the file, reading the file. Okay. Now we want to see this work, right? We want to see that exception work. So let's go ahead and remove cats. So I could go ahead and I could do a cut and then move it somewhere else. Let's see now. I don't use this editor a whole lot. I would think that you could then navigate up or down on here. Or I could just come into here and I could just go ahead and delete the file from here, right? What I wanted to do is I wanted to go ahead and cut it and put it somewhere else, like cut it from here and say, for example, just put it here. That's what I wanted to do. And I'm sure you could do that inside of here. See how it's gone, right? But I'm not too familiar with the editor on here. So let me go ahead and run it now. And the file, the except block caught. So it's reading the file called cats. And it says, well, what happens, it's trying to read it and it can't find it. So then it says, sorry, I can't find that file. So this is working just fine, just fine. Okay. And go ahead and close those. So close my output. Now let's talk about silent cats and dogs. Okay. All right. So that would be number 9. So the modify your except block in exercise 10.8 to fail silently if either file is missing. Point output if cats.txt is absent. So here we have on line 12, instead of saying something, we're going to go ahead and pass. We're not going to say anything. So you're expecting just to have something saying that, that the dogs file was read. So let's go ahead and do that. And yes, it's reading the file of the dogs. Excellent example of the pass statement. Now let's go on to 10.10, common words. Go ahead and close this one. Let's look at 10.10. It says visit Project Gutenberg and find a few texts you'd like to analyze. Download the text for these words. or copy the raw text from your browser into a text file onto your computer. You can use the count method to find how many times a word or a phrase appears in a string. For example, the following code counts the number of times row appears in a string. Okay, so that's how the count works if you use the word row. In this case, we're going to go ahead and we're going to do chaining. You remember method chaining? That was a topic introduced in the previous chapter, or was it in a previous video? How's that? Where you go ahead and can use more than one method on one line. So instead of saying something like line.count and then line.lower, you can go ahead and do them both, at one time. Or, yeah, you could do them both at one time. Yeah. So notice that converting the string to a lowercase uses the lower catches all the appearances of the word that you're looking for, regardless of how it's formatted. So that's something you need to look out for when writing a program that reads the file you found at the Project Gutenberg and determine how many times the word the appears in each text. This will be an approximation because it will also count words such as then and there, because then has the in it. Then it also asks us to go ahead and try counting the with a space after the E. Now that would reduce the count and be more precise. So when you put in a space into the string, we see how much lower the count is. So that's excellent thinking. So this on line 17, the when you try to count the, it's gonna go ahead and count words like then and there, but THE space is only going to count the. Excellent. So let's go ahead and run this. So it says the appears in Alice about 2,500 times, 2,505 times. The with a space appears in Alice.txt about 1,689 times. Now, if you wanted to just dumb this down, you could just go ahead and do the same program on a text file that has maybe one sentence and test it, or maybe a paragraph, something that you could verify with your eyes. I would want to do that because, I would like to go ahead and verify every single word personally on here, right? So let's go ahead and look at what happens here. So the program kind of starts on line 16. I say Alice.txt is assigned to file name, right? And then I call the method count _ comment _ words, and I pass it the file name, and I pass it the with no space. I do it again with the with a space. So we come up to our method definition up here at the top on line 1. And this method definition has 2 parameter variables, right? On 17, we have 2 arguments. So file name goes into file name and the goes into word. Then we have a try, except, else scheme. In the try, we try to open the file. Then we go ahead and read it, the whole darn thing. Remember the read method reads the entire file and puts it in contents. Okay. And if it doesn't find the file, it's going to just not say anything. Else, if it does find the file, in other words, if the try is successful, I'm going to do this method chaining. I'm going to say contents.lower.count. I'm going to do 2 things at one time. Okay. And assign that to word count. Then finally, I'm going to go ahead and construct my formatted string and say, the appears in file name about word count times. That's my string. my formatted string that I'm going to call message, MSG. Then I'm going to go ahead and print message. Excellent, excellent, excellent example. Many concepts going on here. I mean, let's look at everything that we got. I mean, on here, I've got file management, or I'm dealing with. I'm working with files in Python. I'm working with exceptions in Python, and I'm also working with methods, or yes, functions is what I wanted to say, and methods too, because when you have an object and you use dot notation, this is a method, whereas this is not within a class. So on line 1, we have a function. So on line 1, I have my method definition, function definition, which I can expand and collapse with these arrows. And that's a good thing to do, because sometimes people write code in the wrong place and they think that it's inside of here, but it's outside. Like, these lines here, something, it's common to like these 3 lines here, that they would, if you started typing them in here, indenting it, they would be part of this block, right? So then your program wouldn't work right. So that, my friends, that is the end of this section on exception handling. Really great. It's amazing how much your author was able to put into this chapter. This chapter is about files. We learned about reading from files. Then we learned about writing. Then we learned about exceptions. And then we're going to go ahead and learn about JSON, another way of storing things inside of a file. Each one of these topics could very easily be expanded on. And I think we got just enough to understand and be functional with text files. I mean, you could go haywire with this topic, because we could then talk about what about binary files. So let's say I have videos and images that I want to work with. What that wouldn't be a text file, that would be binary. And that's, guess what? That's another chapter right there. So you got to love this stuff, because it never ends. It never ends. You're always learning, and it makes the time pass by and keeps your brain sharp. So, but other than that, I want to thank you for listening, and I hope to see you in the next video.